My name is Jeffrey Kesting. I'm the Digital Technologies Operations Manager for NobelProcera North America, supporting all of our digital technologies, support and training. The focus of our webinar today is going to be exocad, but just quickly, a little brief background about NobelProcera. Some of these numbers you can see here with implants placed worldwide. These are going to be even more than this now. So this slide is probably from a little while ago. So these numbers will be even higher. The point here is we really have more experience, more science in the industry than anyone, and these implant-based restorations, implant surgery in general. So, and what we can really do with that, with a powerful tool like exocad CAD software, is we can design our NobelProcera screw retain restorations, and we're going to talk about that as well. Our focus will be exocad here, designing NobelProcera custom restorations. So as I said, exocad, this is a tool that's been around, a software that's been around for quite some time now. It's become more predominant now in the North American market than it previously was. It was a little bit more popular in the European markets, but now we see it more over here. And it's a very, very powerful CAD software for dental design. And this is referring to their DentalCAD, exocad DentalCAD software. And we have the ability to design all restorations through this software, where we can send to NobelProcera for manufacturing of our screw retain restorations. So this is just a screenshot video here of a single crown, and we're going to actually do a demonstration here just in a couple of minutes, where I'll bring you through a screw retain crown for NobelProcera, and also we'll do a bridge as well. So this case here was just a quick design. I was actually just doing a crown with an abutment. So that's easily done in the exocad software, as you can see here. And we're also going to go through in a live design as well. We're going to do a NobelProcera zirconia implant bridge to show how that's designed. You can see here we have a partial implant bridge that we're designing here. You're going to see how the virtual gingiva works, how we can utilize our angulated screw channel. We'll talk about that a little bit as well. With exocad, we're able to design our NobelProcera custom restorations, and this is their premium portfolio of custom prosthetics, very high-end implant restorations. And that's due to our manufacturing process, which we'll talk a little bit about as well. And NobelProcera and NobelProcera, we're always looking at ways of developing innovation and improving innovation in our workflows between the clinician and the dental lab, and ultimately leading to more predictable, successful treatments for patients. That is always the goal here, and we're going to talk a little bit about that. With NobelProcera restorations, we started CAD/CAM in dentistry over 30 years ago, and still continuing to lead in many ways. So we have these 30 years of experience with our manufacturing process, and we have an industrial manufacturing process that is unparalleled in the industry. And with this, we can achieve excellent results with our authentic restorations through NobelProcera. With the product offering for NobelProcera, these are all, of course, custom restorations. We have in zirconia or titanium. And what's important here is our NobelProcera restorations have either lifetime or 10-year product warranties. That's even in the patient's mouth. And the way we can do that is with our precise manufacturing processes, where we have that 10-year warranty even in the patient's mouth. If something goes wrong, we will replace that restoration free of charge. And we can do that because we do not compromise on anything when we manufacture our restorations. We have an industrial manufacturing process, as we'll talk about a little bit as well. And when it comes to manufacturing zirconia and titanium, we can do this in a very, very precise way. When we're talking about an offering for NobelProcera crown and bridges for screw retain, these are going to be, again, in titanium or zirconia. We can do this either with a full contour zirconia crown, which you're going to see that design here just in a couple minutes when I go through exocad and do a design of a crown. You'll see how easily that's done. We can also do a very array of cutback designs, custom cutbacks, and then we, of course, also have our traditional titanium custom abutments, which we can also design with a cement over crown very easily in the exocad software. So with the product portfolio offered with all the NobelProcera implants, of course, titanium, as we just spoke about, but then zirconia and all the supporting shades that you need there. And what's important, which was really a unique difference between NobelProcera, NobelProcera, and competitors with an angulated screw channel. Again, we invented the angulated screw channel. That's why we can put that little R next to that with NobelProcera. So this is a true angulated screw channel. And this is not something like other products may have in the industry where it is a hollowed out titanium base or a scooped out base. This is a true ASC. So we do mill in that true angulated screw channel with just enough room for that screw head to pass. So that will be in zirconia. And we can change that screw channel up to 25 degrees 360 around the crown, as you'll see. And we'll do this in the example in exocad so you can see how easily this is done. So this is available with our bridges and, of course, our single screw retained crowns as well in zirconia. So you can see here, we're going to be able to plan this in the software and we can get some really nice results. And this, the ASC bridges and single unit screw retained crowns utilize the OmniGrip tooling. So this is a 3D ball hex, so we can get in at an angle, and you can see it's indicated by that blue stripe. The clinical screws have that little blue top on them. The lab screws are all blue. So that's how you can indicate the OmniGrip tooling. And with the angulated screw channel, again, this is a cement-free restoration. So again, we're not cementing a tie base or something like that. This is true cement-free screw retained restoration, and that's going to minimize the risk of cracking and shipping and things like that. With the implant bridges specifically, again, we do have the full contour zirconia available in Vita shades and also, again, available with titanium frameworks as well. Our flagship product with NobelProcera is the NobelProcera Zirconia Implant Bridge. Again, this is cement-free, a lot of flexibility built in here as well. And we just talked about the angulated screw channel. So we are able to achieve up to 55 degrees of restorative angulation with this bridge uniquely. And the way we do that, as you can see here, let's say we had a 30-degree multi-unit placed on the implant, as you can see here. And then we were able to utilize the angulated screw channel with the OmniGrip mini tooling, which is the black stripe here. And we can go another 25 degrees, getting up to 55 degrees. Not saying that we want those implants to be placed at 55 degrees, but we have that freedom restoratively to compensate for that, to get the best aesthetics and strength for the bridge. And that really is a nice advantage to this bridge. Now, this slide is a little out of date. So that's actually 10 Vita shades. So very simple there. Vita shade guide, very easy. Again, cement free. So we're not cementing in tie bases. This is true screw retain friction fit with the adapter. A lot of flexibility with the design of this bridge as well. So you'll see when we go through exocad software, we're able to do all these different designs very easily. We can support up to a 2-unit splint to a full arch, 14 units, and up to 10 implants. So again, not a lot of limitations with this bridge. Really fantastic. We can design it with cutbacks for porcelain veneering. We can do full contour bridges as well. So that would be designed just maybe for some staining and glazing. We can even go what we call a thimble prep bridge that would be designed for individual crowns for retrievability. And then, of course, traditional frameworks and everything in between. And what's important about our bridge, of course, and all of our products at Nobel Biocare is authenticity. They are made to work together. So we're looking here as an example with the conical connection, and we've engineered this connection to work with our custom prosthetics very precisely. So if we look closely here, and this is just an example of an implant level restoration, where the example later we'll do it to a multi-unit abutment. But you can see here, this is a Nobel Biocare custom abutment, and you can see that area below, that 12-degree tapered milling, and you can see with the competitors that is not the same, which they will tell you that is compatible. Clearly it is not. But what happens there when you have that different shape or a different angle there, as you can see here, it's going to put different load and different stress on the implant itself, and that can lead to fractures, and we certainly don't want that. So again, if we utilize the components that were meant to work together, you can minimize situations like this, of course. And if you ever want to be sure that you have an authentic Nobel Biocare NobelProcera restoration, you can certainly just go right online, fill in that information, and the case will come with that identification as well. So you can always be assured that you have a true, authentic NobelProcera restoration. And the way we do things and how we can have this quality is the way we work at NobelProcera, and we've done this for many, many years. And we thoroughly test all of our products at Nobel Biocare, NobelProcera, of course, being a main part of that. And that can be anything from fatigue analysis to gap and load analysis, clinical studies, many clinical studies in the industry, and also computer simulations, so we can see how these products react and how they work before we even get them onto the market. So we thoroughly test everything we do to assure that quality. And when we are producing these restorations, you can see in the example here, this is a zirconia implant bridge to the multi-unit abutment level. You can see there's no adapter here. That's going to go right to the head of the multi-unit abutment and held together with the screw. We measure this in a very precise way with Zeiss measuring equipment. And this is, again, unparalleled in the industry. And you can see how we measure this. We have very, very tight tolerances for these products. So we can measure the axis and the locations of each interface, and we can physically measure that with a probe after the product has been milled. And if that does not meet our very strict tolerances, we will start over. We will never rework a product. So if there was just a slight bit off, maybe in the seat, like you see here, we would not try to correct that. We would completely start the process over and remake the product until that meets our internal quality checks, as you see here. So no one in the industry is doing anything quite like this. And just to give you an idea of the accuracy that we're dealing with our products and the tolerances that we work within, this sphere here in purple is the stylus. That's the physical aspect that touches to measure the bridge or the restoration. You can see a human hair here to the left, the human blood cell, bacteria, and then our product tolerance there. So we're dealing in very, very tight tolerances. This is why we need to use this industrial measuring equipment to do this. And that's the commitment from NobelProcera. And every single NobelProcera product is a certified medical device. So we adhere to all the medical regulatory bodies across the globe, of course, the FDA, the BSI, and we're regularly audited by these organizations and usually pass with flying colors, which we're very proud of. Now, I wanted to touch on this just briefly because when we're talking about exocad, it's maybe not just about single unit restorations, but this could be about full arch workflows with photogrammetry, something becoming very popular in the industry where we can capture implant positions in space in a very, very accurate way below 10 microns. And we can utilize exocad for this process. So just to give you an idea of what that looks like, we can work from an interim to a definitive prosthesis in this example here. So we have interim scans that can be with our intraoral scanner. We scan our, what we call them the dominoes, or those are locate the implants in our photogrammetry system. We can go for a surface scan with our intraoral scanning. That's when exocad comes into play. Now that we have that data, we've captured the implant positions in a very accurate way. We've scanned our data. Now we can design a bridge in exocad, as you can see here. Now, this will be designed either as a prototype or a try-in. You can see here, this will be a prototype, and this will be 3D printed in this example here, where we can go for a try-in to make sure everything is perfect. And then we can move to our definitive or final restoration, which is the NobelProcera NobelBioCare zirconia implant bridge, which we just spoke about. So you're able to achieve that, and of course, to deliver to the patient where you can achieve those really nice aesthetics and have the strength of that bridge. And what we're able to do, just remember what we were talking about, we can do those cutbacks, full contour, we can do individual crowns. We have that versatility within the software with this bridge, and we can achieve results like this. This is a case that was done by one of our key opinion leaders. He's the owner of Master's Arch. It's Sean Hahn. He's a master dental ceramist, and you can see what he's able to achieve with this material working with exocad. So you can see here, just to give you a better idea of what that looks like. So when we design a bridge, you can see this is a lower bridge that Sean designed here in exocad. We mill that with NobelProcera in our Mahwah, New Jersey milling facility, and then he's going to finish that bridge to get results that look like this. So that's what we're trying to achieve here, and working with exocad for NobelProcera, NobelBioCare restorations, this really brings it as a home run, brings it all together, and that's what we're trying to achieve here. So we can support you with different workflows. Of course, exocad being our focus right here, so we're able to receive those files into our manufacturing facility in New Jersey to produce those high quality restorations. Now with exocad, I'm going to go through an example here. We do offer some education with exocad as well. I teach courses in our New Jersey facility, and maybe we'll do some remote as well in the coming quarters. But we will publish this information as we release courses. We just completed a couple, and we get more on the books very soon. So you will see that on all the channels through social media, on our websites, and of course, you can stay in touch with your local representatives where they'll be able to get you into any of those courses that we have coming up. So with that, I'm just going to jump over to, of course, the exocad software, which everyone came on to see today, and design some NobelProcera restorations. So you could really get an idea and see the software in action. So what I have here is I've set up a case for a NobelProcera full contour zirconia client. I'm just going to click on it here so you can see how we set the case up. The exocad software you're seeing here is the NobelBioCare version. So you will see it's branded with NobelBioCare, and it has all the NobelBioCare workflows for the NobelProcera restorations here, as you can see. This is still native exocad, so you still do have all the default parameters, so you can certainly work through those, but we've made it really nice and easy for you to design NobelProcera restorations where you can just simply click on them here in the material chart, just fill out the options parameters for what you're doing, and then you can easily design this case, and it has all of our parameters baked right into the software, and then you can easily send that case to us right through DentalShare as well, right from the exocad front end. So very, very streamlined and easy to work with exocad and NobelProcera. So just to show you what this looks like here, I have just a demo case here with a full contour zirconia crown. We're going to do a number 14. So I'm going to click on design here. I just set up the case previously. And you can see here, this is the latest version of exocad. This is version 3.1 that we're utilizing. You can see this is branded. This is the Nobel version. So you'll see the N on there, of course. And I'm just going to load this scene file. And again, you'll see it branded with NobelBioCare. But of course, this is the native exocad software. So as you can see here, demo case, I have very, very big sulcus, which just works well for demo purposes so we can demonstrate things. And what you're looking at here now is the dental CAD software of exocad. So this is where you're going to be spending the majority of your time working on designing cases. Exocad does a wonderful job of bringing you through that. And it's what they call the wizard, which you see down here on the bottom left. And this is essentially a guide that brings you through the software so you know what to do next. You have the ability to jump to an expert mode where you have those tools and functionalities when you need them. But the wizard is a really nice workflow. Even experts in the software will probably still work through the wizard. So you can see here, it's going to bring us to this aspect here. After I've marked all my implant positions and brought in all my scans, we're going to start designing the crown. You can see here, if we want to design an emergence profile, just as an example here, as I said, the sulcus is humongous. I'm just going to start to click a series of dots here so you can see what this looks like as it's essentially setting a margin for our emergence profile. I can make a double click there. I can come in, make any adjustments. That's essentially where we're going to start a custom emergence profile. And you can, of course, add more points, delete them. For the sake of demonstration and time, I'll just leave that set the way it is there. But of course, you have adjustments here on the left in the wizard. I'm going to click on next in the wizard, which brings us to our next step. Now, when I set up the case, we can work with library crowns, which exocad has a really nice set of library crowns. But we can also copy or mirror any existing teeth in the arch. So in this example, I set it up for both so you could see this. So in this example, let's say the tooth on the other side here, I want to grab this one here. All I have to do is click on it, and you'll see here now it turns it yellow, and I can literally bring it right over to where I want it, flips it around, and I can click again, and now it sets it up. Now I can start to design this crown, and that would just be perfectly aligned with the anatomy with these crowns in this case. So that's very easily done. As you can see, again, you could copy neighboring teeth or mirror teeth on the other side of the arch very easily here. I'm just going to undo that here, or just go back and next. I want to show you what the library workflow works, how that works as well. So instead of copying a tooth here, I'm just going to click on next. So you'll see what the software will do here. It finds our mesial and distal contacts automatically, and now you can see it brings in a library crown so for us to design. So you have this workflow here as well. This is the default crown library in here. You can change this with different teeth here. I won't go through that now, but there are different teeth libraries which you can utilize. So when we're setting up this crown here, you can see we have a visibility editor up on the top left here where we can make things more or less transparent. So you can see I have my crown here. Now I have some controls, and in the wizard, I'm under the place model tooth. So here's where I can come in and really position this tooth. I'm not going to spend a ton of time getting this perfect at this time, but just to give you an idea of how we can position this tooth. This is just a basic position that we're going to get into. Now you can see as I pull that crown closer to the opposing, you can see here it's starting to merge that in. It's starting, see how it's starting to form there? There's different ways you can do this. I can also move to this option here, which is as the moves into contact. If you want to see your contacts, I can switch this in the visibility editor to contacts. As you can see now, I have pretty heavy contacts, but this is a nice function, and it's you can move the crown, and as you move this, it will bring it right into occlusion. So wherever you contact either the adjacents or that occlusion there, it'll automatically cut that in for you to the degree that you set. In this case, it was just set at 0. I can also make the anatomy flatter here if I needed to. You can make all kinds of adjustments here, but we'll just say for the sake of moving on that this is okay for this point. I'm going to click on next in the wizard. Okay, now this is an important part. What we have available with the full contour zirconia NobelProcera implant crown is the angulated screw channel. And this, where we can change this, I'm going to turn off the opposing so you can see this here. And under the abutment bottom section of the wizard, you can see here where we can change things with the emergence profile. I'll just show you that real quickly here too. You can see we developed an emergence profile. When this is green, this magnetizes to the tissue. If I turn that off is where I can move this freely. So you can set up a perfect custom emergence profile here with these tools. But what's also available under the advanced section of that abutment bottoms is this section here called angulated screw channels. So we have two ways we can angulate the screw channel. We can go to clickable, which just means you can click anywhere on the crown and the screw channel will follow, and you can change the degree. You can also go to draggable, which brings in this line here. It's got a little sphere up there. Now you can see those graphics come in. So as you do change that screw channel, you'll see exactly where you're going to place that relative to where the actual screw channel is. So really nice features here with this restoration, very easily done within exocad. I'm just going to say that's fine. I'm going to click on next here. Okay. Now this brings us to the freeforming section of the wizard. So as you would imagine, this is the section where we can come in and make any type of adjustments that we need here. So just to show you how this works, I'll turn off the antagonist really quickly here. We can move our crown in a lot of different ways. So we have this free section, of course, where we can add material. We can remove material. We also have an anatomic section where you can move different presets and different sections of the tooth. And really what it is you could just move bigger or smaller areas. So you can see if I'm on cusps here, I can literally move to an area to move any cusps of the tooth or any areas. Under tooth parts, essentially just grabs a bigger area. So maybe I want to push it more into the contacts, let's say. I can do that. I can move the entire tooth kind of down from that cervical area. I can move that up and down. And then if you wanted to adjust any ridges, so like a triangular ridge, marginal ridges, you can easily do that here with this tool as well. Sometimes if you check the occlusion here, you can just see now maybe I just need to bring down some of those areas, as you can see here. And you can see where we're contacting there as well. There's also a cut intersection. So you can see here we have contacts. So I can always go cut intersections. And what that will do, that will cut everything in. So you can see it cut into the tissue here, and it cut our contacts in as well. Okay, so I can see here I have good contact here. But now I'm going to turn off my jaw scan. You can see we do have some work to do here. I'll turn off that adjacent. You can see what this did is it cut into the tissue, as you can see. So we do have to do a little work here. So I'll go to my free section. I can work in my smooth flatten, and I could literally just come in and make any of those changes just to smooth things out if I needed to, because obviously I don't think we'd want to have the crown quite look like that. Okay, so I'll just quickly go through a design here. Again, if you need to add material, you have all the controls here. So if you needed to add material, again, you could cut this in as well. I won't take a lot of time designing here, but again, that's going to be designed right down to the emergence that you had set for this. So we'll just go and smooth maybe some more areas here or add material. So you can just see how that works. And then smooth flatten. So you can use all these tools in conjunction with each other to design your perfect restoration. So certainly not what I designed here, but I think you get the idea. Once we're done designing here, let's say I can click on next again in the wizard. And you can see what that's going to do here. Brings us to our screw axis hole. So again, you can see right where that is, and we're going to mill that in perfectly for you with the NobelProcera screw retain crown. I'm not going to change that, so I'm going to click on next. And you can see just that simply, it designs the whole crown for us. What's called merge and save restorations. Now you can see as that crown becomes a greenish color there, it saved all our restorations and saved all our modifications and any freeforming that we did to that emergence that we designed. And then you'll have the availability to now send that to us to manufacture. So what I can do now is click on I'm done and then click next. And what this will do is this will bring us right back out to the dental DB, as they call it, where we set up our case. Now, what we can do is simply click on dental share. Okay, just signing in here. Okay, there we go. You can simply select production, then automatically, because we have the Nobel configuration here, NobelProcera production, NobelProcera at exocad, milling center for Nobel Biocare. That will come to our Mahwah, New Jersey manufacturing facility. And you can see it automatically checked as production data. That's all we need here. You simply click OK. That will come to us where we'll be able to create that restoration. One important part when you are doing this, in the account ID field, it is critical that you put your Nobel Biocare account ID right in there so we know right where that's going. Once that's in there, you go to dental share. As I said, you can send that restoration and we'll receive that in New Jersey and have it back to you in a couple of days. And then you can finish the crown and you'll be ready to go. Quickly, I want to jump to another demonstration I have here to stay on time. I do have a full arch case that I wanted to show you what that looked like as well quickly. So I'm just going to grab that here. Going to load that again. And again, I just set this case up here. And what we set this up for is what's called an anatomic wax up. So we're going to bring this through, again, design library teeth as a NobelProcera implant bridge on 4 implants on multi-unit abutments. So I'm just going to click on design here. And some of the things you'll see are going to be very similar when we designed our screw retain single crown. But again, now you'll see the virtual gingiva section, obviously. I'm going to load the scene file here. Okay, again, demonstration case here. We have implants on 4, 7, 9, and 13. They're all multi-unit abutments. Now, what the software will do, I've already indicated these here. It'll ask you if you want to change the emergence profile here. We don't, because these are stock cylindrical abutments, and we're bringing that bridge right to the head of those multi-unit abutments. So I'm just going to simply click on next right through each one of those tooth positions. Now you can see what it'll do is it brings in our library teeth, but now, of course, we have a full arch of teeth. Again, you are able to change these libraries as well. In this example, I didn't have an opposing on here. Of course, you could have one, but just to show you here, we're going to work right to this diagnostic in this example. So you can see here, I do have teeth. There's a lot of different ways to move these around. Just for the sake of time here, I'll just do this so you can see here a little bit easier. Okay, I'll move them all. Like I can move them all. So maybe we need to bring those teeth down and get them set up to where our diagnostic is. So again, we're going to probably be following that. And then, of course, you can move the teeth individually here as well. I'll just do this very quickly for the sake of time because I want to show you some of the other steps. So we'll be quick with our bridge design here, but you have the availability to get these teeth exactly. Now, there's other workflows that you can follow as well where you don't have library teeth. You could simply design the bridge right to your diagnostic that you have here. Like in this case, you could certainly do that. Very easy workflow. I'm just going to try to position these teeth a little better. And of course, you can make the teeth bigger or smaller as well. I'll try to do that here so we don't have any too many interproximal situations here. And we can move teeth. Just do this really quickly. Obviously, you would spend time here designing your real bridge to get these exactly where you need them to be for the case, but I'll just do this very quickly so you can see some of the other design controls. Make these just a little bit bigger here. Okay, so we can get this looking a little bit better here. We'll say that is fine for this, just for this, moving on here. Okay, so once I've done positioning these teeth, and there's different ways to do that, did it quickly here. I'm just going to click on next. Again, now you will see the angulated screw channels, right? Because we can do this now on top of the multi-unit abutments with this bridge, and that's where we get up to that 55 degrees of angulation if we were on a 30-degree multi-unit abutment. So just like we did before, we can go right to the Advanced tab. We can go on clickable or draggable, and we can move these screw channels anywhere we need them. Okay, so you can see with these, maybe they might be a little interproximal, not a really big deal here because we're going to design some virtual gingiva, as you'll see here in just a couple of minutes. So again, get these screw channels exactly where you need them to be. I've just moved them around randomly here on this example, but you get the idea. I'm going to click on next once that's done. Okay. This will bring you to, of course, freeforming. So again, you have all the same controls that we just talked about. So you could come in here. Obviously, you can see my centrals. I have some some problems there. You have all the anatomic is here as well. So let's say you wanted to just move that tooth maybe a little bit like that or something. Make things look a little bit better here. But you have all the free-forming tools here. Now, you also have True Smile, which is over here on the right, and there's some different tools in here, ways to look at things. You have this light view, which you can move to. And why I like to use this sometimes is if I wanted to design some of the secondary anatomy. So what I might do here is I might go to my add remove, move my brush size all the way down on my small brush here and move the strength all the way up. And maybe I want to come in here and cut in some secondary anatomy. Let me make that brush a little smaller. But if I just wanted to do some of this work here, I could do this. Now, some might say, well, my laboratory mill can't do this, so why am I putting in all this extra work to do this fine design? Our mills can achieve this. So if you want to be detailed with your secondary anatomy, and that bridge that I showed earlier in the presentation from Sean Han, he did a bridge with us once, and there was a tiny little hole in between the two centrals. It was like a little diastema there, and it was so small, like a pinhole. And we did the bridge, and he looked at it, and as we were looking, I went, oh boy, that's not good. But he said, no, this is great because he designed that tiny hole, and it actually showed up, and we milled it. So he was thoroughly impressed by that. So if you want to be detailed here, you definitely can be. Maybe I'd want to do a wash over this after. I could certainly switch that back here, and then maybe just do a little wash in there. So you have those controls there in exocad, and you can ensure you're going to get those designs. For the sake of moving on here, I'm going to click next and say those look okay. So again, this will bring us to freeform. If we need to cut anything in, you can cut your intersections. Okay, then click on next. Okay, you can adapt to your pre-op here if you wanted to. Now, again, I said there is a quicker workflow where you're just going to the pre-op. You can make any adjustments and freeforming off that, and you're ready to go. In this example, we brought in the library teeth as if we were designing a definitive bridge. So all I'm going to do here is click next because I'm not going to adapt it to that pre-op. Now what this will do, this brings us to the virtual wax up bottom section. So we're going to design virtual gingiva as well for this full arch case. And to do that, we need to block out undercuts essentially. So what the software will do automatically is a virtual survey of the model. So this will automatically block out undercuts. You can change the settings for that. We have it at 0 here. So what this will do, you'll see in a second here, is give us a blue model, which is a blocked out model. So now we can design our bridge on that. That looks great. We'll just click on next. What it's going to ask us here is if we want to design a single gingiva for all the neighboring teeth, or we want to do separate gingiva parts for each planned bridge. So what that means is, do we want to do one full gingiva or different parts? So maybe, for example, you want to have maybe just virtual gingiva in the anterior, but in the posterior you don't. So you could do it by sections. In this example, I'm going to click yes. We're going to do one virtual gingiva. So you can see here, it brings in my blue model with my teeth now. Again, I can adjust the light. This light you can move anywhere you need to. So what I can do is I'm just going to start to click. You can click anywhere you want just to outline where your virtual gingiva is going to be. I'm going to do this quickly here. So you can just see. You can click these points anywhere you want or as many as few as you need to outline this. And again, if you make a mistake, you go, uh-oh, I click way down here. You can grab those and move them, put them where you need them. Again, I'm just going to do this quickly for the sake of time. Okay. Okay, when you get around to the original plotted point, you can do a double click in between them. And what that'll do is that will connect them, obviously, and connect the boundary. And now it'll create the virtual gingiva. It just takes a few moments here. And there it is. You can see now I do have that virtual gingiva. If you had to make any changes here, you can again go in and adjust any of these points, add more, take them away, do whatever you need to do, and then click apply, and it'll adjust those changes for you. I'm just going to click on next here for the sake of time. Now what it does is it brings in our gingiva, but you can see now it's yellow. So we have the ability to freeform this. So you can see here, again, we're in freeform gingiva now. So instead of the tooth parts, we now have a small region and a huge region. So the way this works, let's say in the cervical areas, I could just click on the huge region. I could just bring these areas down. See, just something like that maybe in your design. So maybe I'll just quickly bring that down. Just quickly, something like that. You could do that again on the lingual. You can make any adjustments here that you need to, closing in anything. So it'll just move an area, and that's not just up and down. You can move that area anywhere you want. See how it'll just, so you can just grab a section. And then we also have small regions. So sometimes where that works well, as an example, is interproximal here. If I have to bring down or bring up, in this case, any tissue there. So interproximally, maybe I could just position that. I could move it out too if I need to. Okay, so I'll just pull those interproximal areas down because this is going to be a solid monolithic bridge, right? So maybe I just want to make sure I don't have any. And this is what I was talking about, the little pinhole that Sean had designed right in there. And we actually, just like this here, and we milled that. That's what we can achieve. It's pretty amazing stuff. So you can be assured that your design will definitely come through with our milling strategies and our mills, of course. Now you can see if you want to do any freeforming, we have the ability to do that here as well. So you can simply click and add on any material here if you wanted to, or take away. So you could come in here and make those tooth eminences, those root eminences more prominent if you wanted to. I won't go too crazy here, but you get the idea.
Exocad.
Okay, so you can see here. Maybe I want to take some material away. You could come in and do that. If I just hold down on the shift here, maybe I want to cut in here a little bit. You get the idea. I'm probably making more of a mess than anything. So also you can do, a lot of people like, you can just do a quick wash right across maybe like that. Something like that. You have the ability to adjust that. You'll notice there that it's keeping the intaglio fixed. You can turn that off if you want to adjust at this point. You could come in here and you could just unclick the keep bottom boundary fixed and the desired thickness, and then you could do this. I just do it at a different step when we bring this together as an anatomic bridge, and I'll show you that as well. So I'm just going to come back in here. Again, do any free-forming that you need to, any material that we need to add here. Maybe I need to add material there. You know, you have all the design controls here to do this. You know, just, and then I'll come back in and smooth and flatten some of that. Okay. Maybe add a little bit of material there. That doesn't look very good. Again, you can add material anywhere you need to. And then I could come in and smooth the areas here as well. So I won't go too crazy, but you get the idea here. You can be as detailed as you need to be with designing your bridge here. So I'm just going to click on next. Once I'm done freeforming my gingiva, and what the software will do now, it will merge and save this. So it's merging all your designs together to make a wax up in one solid piece. So we did all of our design of our teeth. We angulated our screw channels. We made an emergence profile, perhaps. We designed virtual gingiva. So what the software will do now is it'll merge all of that together, where you'll have the ability to do further freeforming and designing, which I'll show you here. And then the final merge it'll do before we send it in is it'll merge those implant positions. You'll see when it goes through these different sections here to design the bridge, that will pop up there. Also, if you have any questions, feel free to pop those in the chat. we'll be happy to answer those for you as well. And we're going to give you some links here at the end for some resources. And we have a short survey that we'll send out to you to ask you to fill that out in just a couple of minutes if you don't mind. So while we're finishing this bridge here, you can, of course, pop in any questions that you may have. If you're new to using exocad, or maybe use some competitive software and thinking about working with exocad and working with NobelProcera custom restorations. You can see here the bridge is just coming through all those. The more you do, this is a bridge. We have 4 implants, but it takes time to merge all that data together. exocad does a really nice job of doing that. exocad is also a great software, not only for design, but also for merging data as well. It does a very good job, and editing meshes as well. Exporting STLs, importing STLs, very, very easily done. So you can see here now it's generated the wax up for us. And now what you can see here it's done is this has brought in, now we have this anatomic bridge. So it's brought everything together. Right now, everything is yellow. Okay, so what I can do here now is do further restorations to say maybe I want to adjust this ridge here. So what I can do, I can come to my free forming, just like we had before, exactly the same tools. But now I can come in and I can just free form this entire bridge. And I'm going to keep my abutments on there because I obviously don't want to violate that, because if you go through there, you could violate minimum constraints. You'll see that in our software, and won't let you send that through if you violate that, so you'll know that. If you're doing anything else or provisional bridges, you could do that. So a good idea, just keep those abutments on. And you can see here, that's our color coding to where we are relative to our jaw, right? Which you can see here, that's it. You can bring this on as well, and you could smooth and flatten from here if you wanted to see it that way as well. I'm just going to continue to come around here just very quickly and take that off just so it looks a little better here. You can make any adjustments you need to. I'm just getting rid of some of this ridge because this is a demo model we were working on there, and it does cut into that ridge quite a bit. So I'll just take that off. Make our bridge look a little bit better here, maybe. Now, a good idea, always put that model back on, because you see what I've done here. I probably created some type of gap here. So let's say I need to go correct that. So what I can do, I can come back to my add remove perhaps, and I can add material up into here now to make sure that's a little bit more aesthetic for the patient. Okay, especially if it's a definitive restoration, we want to make sure that's just absolutely perfect for them. But you have all the controls here to be able to do that. So maybe I needed to add a little bit more there as well. Increase my size a little bit and my strength so I can go and fill that in there. Now, you could also use the anatomic here as well. But remember, when you move the anatomic, this moves everything. So you can see I can move tissue, but it also will move teeth. So remember, you're changing the look and feel of those teeth. Like you can see here, if I was doing free, like if I smooth, see now I've lost maybe, some of that cervical area. So maybe you wouldn't want to do that. Some tricks here where you can just actually pull it and get it back in if you needed to. But yeah, it's a lot of design. There's a lot of information online. exocad has some great groups for design. There's some amazing things that people are doing out there, probably a lot better than my ugly looking bridge here. But yeah, you can see what you can do. You have freeform design control here, which is really great. Very powerful tool. So now at this point, when we're done, let's say we can just simply click on next. And what this will do, now it's merging all of our implants, our square, everything together to make that final bridge. We didn't do it in this example, but you, of course, could do cutbacks here. You could do thimble preps. You have all that availability within exocad here. And we'll just click on next through this. And now it's going to merge our bridge together. And again, that'll give us the ability to say, I'm done, bring you back to the dental database where we can send that into NobelProcera manufacturing. So I know I'm down to the last 15 minutes here. I guess we can open it up for questions. And I know Sherry is monitoring our chat there, which I haven't been. So yes, and Arjun has as well. Thank you. Arjun, I didn't know if there was anything you needed to add as well. Okay. Okay, also, if there's no questions, you'll notice there are links in the chat. So we have resources for you. So we do have training videos for very similar to what I just showed you here. We have them available on our open access page on nobelbiocare.com. There's the link there for that. You'll get that homepage. And we also have YouTube, a Noble Biocare YouTube page, which we give you access to. And then more importantly, right at the end there's a post-webinar survey. If you don't mind, take just a couple of minutes, follow that link and fill that out. We would greatly appreciate it. So I guess we can leave it open if there's anything to add or any questions anybody has. Of course, you don't have to put them in the chat. You can, of course, ask them to live if you'd like as well. So here's our bridge design. That's all done.
Hey, Jeff, I think Josh had a question.
Okay. Sorry, I didn't see in the chat there. To go back up. Yeah, with the recording. Yeah, we'll share that recording.
I think it was more on the specific design on the underside that you can select.
Oh, okay. Is there a specific design of the underside that you can select? Hey, Josh, no, there's not. So you can just contour that to your model, to your ridge. And like I did, you could go in and then just freeform. So there isn't anything stock there for design, but that'll adapt to your jaw there. And then you can relieve that to whatever you need to. Okay, now you can see that's brought back out. And again, if we're going to share, send that case to Nobel, we simply click on Dental Share. It has all the information already because we have the Nobel version, production. You click NobelProcera and click OK, and it's coming our way. Now in exocad, we have under indications and materials, you'll see here, we have NobelProcera production. I just want to show you what this looks like. So if I drop this down here, what you'll see under dental share, of course, is Nobel Biocare. You see our logo. So if you ever want to do NobelProcera restorations, and they're going to come to our manufacturing facility, anything screw retained, you're going to select this right here. If you're working in any other workflow, there's the default, which is up here on the top, which is going to give you the option to do essentially whatever design you want. But with NobelProcera here, with Nobel Biocare, this will be all our workflows. And down on the bottom, if you want to make that the default, you can just click that little check mark there and click OK. So now every time you come into the software, it'll be set for Nobel, but you do have that ability to go through default to do anything that you want in the software, which is great. A lot of flexibility there. Okay. You're welcome, Josh. Okay, is anybody, any other questions? Okay. Well, I guess we still have a couple minutes left, but just thanks everyone for their attention. And if you could just, again, take that survey, we pop that in the chat there for you. It's very quick. We would greatly appreciate it. So thank you very much for your attention. And that's where we're end the webinar today. Take care.